Hello students, this is Nilanjana Sanyal from My Math Friend Online and ePorashna. As I have said before that any quadratic equation can be solved by the method of factorization or by taking the help of the quadratic formula, right? So how can we factorize a quadratic expression? We can factorize a quadratic expression by taking the help of the algebraic identities or by the middle term splitting method or by this method, the completing the square method. So we have done sessions on using the algebraic identities to solve quadratic equations, as well as we have done solving of quadratic equation by the middle term splitting method, by factorizing the quadratic expression by the middle term splitting method. Now today in this session we will be taking up this completing the square method. Okay. So I have taken up two sums. X squared minus 5x plus 6 equal to 0. This is the first sum and this one is the second sum. 2x squared minus 7x plus 3 equal to 0. We will be solving both of these two sums by this completing the square method. Now, what is the difference between these two terms? Sorry, these two sums, rather. Now, let us look at the very first term of both of these two sums. For the first sum, we are having the first term as x squared. It is a perfect square term. We could have had 4x squared or 9x squared or any other perfect square term. X squared is x whole square, 4x squared is 2x whole square, 9x squared is 3x whole square. This very first term should be a square term in order to fall under this section. And for the second case, we are having a 2x square as the first term, and this is not a perfect square because 2 is not a perfect square number. Okay. Now we will be solving both of these two sums by the completing the square method, and we will be seeing what is the difference between the procedures. Okay. So let us start with the sum number 1. Now, sum number 1, this is the first term x squared and this is the second term minus 5x. We will be introducing a third term in between after minus 5x so that we can take these three terms together and express these three terms in the form of a minus b whole square or a plus b whole square identity, depending on whether this sign is a minus or a plus. If it is a minus, then we will be taking the help of the a minus b whole square identity. As if this is a plus sign, then we will be taking the a plus b whole square identity. Okay. So let's start. So this is equal to, we write x squared because we will be expressing this in the form of a minus b whole square. If we expand a minus b whole square, what do we get? Right, a square minus 2ab plus b square. So a square is equal to x square in this case. So we write x square. And next is minus 2ab. So we put this minus sign and minus 2. So we write 2. And in place of a, we will be putting x because a stands for x in this case. And it is 2 times x times we will be having a number which will be the b. So b will be representing what? That we should have to think. we should have to write such a number so that when it is multiplied with 2x, we will be getting this 5x. B will be that number, B will represent that number which when multiplied with 2x will be giving us 5x. Because this minus sign is there, so we need not worry about this minus sign. Only thing is we have to have such a number which when multiplied with 2x will be giving us a 5x as the product. So we can straight away write this 5 in the numerator because we have to have a 5. So we can write a 5. But what will happen to this 2? We have to get rid of this 2 as well. Otherwise, how can we get 5x? So let us bring it as the denominator. Let us put it down so that this 2 in the numerator and this 2 in the denominator can get cancelled. And we will be getting a minus 5x as the product. So how did we get this number 5 by 2? We are seeing that there is a 5 over here. We have to bring this 5. So we are writing this as the numerator. Next, the extra number that we are having is 2. We have to get rid of this 2. 2 is in the numerator. So we are introducing a 2 in the denominator so that we can cancel both of these two 2's. Okay. So that 2 times x times 5 by 2 will be giving us a 5x. Okay. Till now we haven't introduced any new term. Now we will be introducing the third term. That is plus b square. So let us write this plus sign. Now what is b? b is obviously equal to 5 by 2 because minus 2ab minus 2 times a is standing for x, a is representing x. So times x times 5 by 2. So b is equal to 5 by 2 and plus b square. So it will be 5 by 2 whole square. Now we have introduced a new term, 5 by 2 whole square. But we cannot do this because this will be changing the value of this expression. This equal to sign will no longer be valid if we just simply introduce one more term in between. We cannot add anything to an equation. The value will be getting changed. So as soon as we add this new term, we have to subtract this as well. So we will be writing 5 by 2 minus 5 by 2 whole square. Since we have added this 5 by 2 whole square, we have to subtract this as well. So we have written minus 5 by 2 whole square because effectively this plus 5 by 2 whole square and minus 5 by 2 whole square when added will be nullifying each other. These two will get cancelled. We have introduced this term just for the sake of the calculation. Okay. But we cannot change the value of the expression or the value of the left hand side. Okay. So that the equation doesn't hold anymore. We cannot do that. So as soon as we introduce a positive term, we have to introduce a negative term as well. And next is plus 6. Plus 6 stays as it is, equal to 0. Now this part, these three terms taken together will be giving us a minus b whole square identity form, where a stands for x and b stands for 5 by 2. So this part is equal to x minus 5 by 2 whole square. Now coming to this part. 5 by 2 whole square is 5 square by 2 square. So what is 5 square? It is 25 and 2 square is 4. So this is equal to minus 25 by 4 plus 6 equal to 0. Now, what is 6? We have to, okay, let us write this as it is and let us take up another step. We will be adding these two, okay? So how do we add a fraction to a whole number? We change this whole number to an equivalent fraction, right? And how do we do that? We get the denominator to be the denominator of the fraction. So this will be having a denominator of 4. We write this as it is, minus 25 by 4. Now 6 is having a denominator of 1. This should be 1 should be converted to 4. How can we convert 1 to 4? By multiplying it by 4. And if we multiply the denominator by 4, we have to multiply the numerator as well as by 4. So we do that and we get 6 times 4 is 24 and divided by 4 equal to 0. Right? Now this is equal to, this part is kept as it is, x minus 5 by 2 whole square. Now minus 25 by 4 plus 24 by 4. So it is obviously a minus 1 by 4 equal to 0. Okay. Now you see this is a whole square and also 1 by 4 is a whole square term. It is 1 by 2 whole square. Right? Because 4 is nothing but 2 square. So we write this as x minus 5 by 2 whole square minus half whole square is equal to 0. Right? And again we see this is in the form of an algebraic identity a square minus b square, where a is representing this x minus 5 by 2 and b is representing this half. So this is of the form a square minus b square. And what is a square minus b square equal to? It is equal to, right, a plus b times a minus b. Very good. So we write that. A is x minus 5 by 2. So we write x minus 5 by 2 plus b. B is half. So it is half. And a minus b, that is x minus 5 by 2 and minus half, minus b. So it is minus half equal to 0. Okay. And 5 by 2 is a fraction, also half is a fraction. Both are having the same denominator. So minus 5 when added to a plus 1 will be giving us a minus 4. So it is x minus 4 by 2. And this is also minus 5 and minus 1 when added together will be giving us a minus 6 by 2 equal to 0. And these two will get cancelled and even these two get cancelled. So we have x minus 2 and x minus 3 equal to 0. Okay. Now since the product of these two is equal to 0, therefore either x minus 2 is equal to 0 or x minus 3 equal to 0. So we write either x minus 2 equal to 0 implies x equal to 2 or x minus 3 equal to 0 implies x equal to 3, right? So we have the answer as x equal to 2 or 3, right? This is our answer. Now coming to the, I'm not doing the checking part because it's very easy. Please do it yourself because this will be lengthening the time of the video. So we have 2 sums to be solved. That's why I am leaving the checking part. Please do it yourself. Now coming to this sum, the second sum, 2x square minus 7x plus 3 equal to 0. Okay, I'm not writing the checking part, but I'm just orally doing the checking. When x is equal to 2, let's do it fast. When x equal to 2, it is 2 square is 4, and this is 5 times 2 is 10. So 4 minus 10 is minus 6 plus 6 will be giving us a 0. And this equation is satisfied when x equal to 2. And from when x equal to 3, this is 3 square is 9 and this is 5 times 3 is 15. So 9 minus 15 is minus 6 and this is plus 6. Added together will be giving us a 0. So x equal to 2 and x equal to 3 satisfy this equation, quadratic equation, x square minus 5x plus 6 equal to 0. So we have arrived at the correct result. Okay. Now coming to the second sum. 2x square minus 7x plus 3 equal to 0. Now over here the first term is not a perfect square term. But we want this to be a perfect square term. How can we make this to be a perfect square term? We will be multiplying by 2. Whatever is the coefficient, if it is not a perfect square, multiply with that very number so that it becomes a perfect square. Not only this term, you cannot just multiply this single term, you have to multiply the entire equation by that term. Whatever be the number, whatever be the numerical coefficient of x square, if it is not a perfect square term or a perfect square number, multiply with that very number. Multiply the whole equation by that very number. So since 2 is not a perfect square number, we will be multiplying the entire equation by 2. So we have, on multiplying this entire equation by 2, we will be having 2x square multiplied by 2 will be giving us a 4x square. And 7x times 2 is 14x, so it is minus 14x. Plus 3 times 2 is 6 is equal to 0. Now we are having the first term as a square term. Next we will be proceeding exactly the method that we have followed over here. We will be exactly following the same procedure. Same path. Okay. So again, we will be taking these 2 terms and we will be introducing a third term since it is a minus sign. So we will be expressing those 3 terms in the form of a minus b whole square identity. So this is 4x square is nothing but a 2x whole square. So a stands for 2x minus this will be 2ab. So it is 2, a is 2x. So we write 2x times, we have to get a proper number which when multiplied with this 4x will be giving us a 14x. Okay. So we can write 14 by 4. There's no harm. If you want, you can do it. You can write, if you cannot think of a proper number, just write, because this is 14, there is 14, so write 14. Okay. And we have to get rid of these two 2's because it is a 14x and we are having these two 2's. So how can we, in the numerator, we are having two 2's, that is 4. So we get a 4 in the denominator. Just whatever be the term, write that as the numerator, and whatever extra numbers you are having, put that in the denominator part. Okay. Now 14 by 4. This you have to reduce to the simplest form. Both are even numbers, so it can go by 2's, and this is 7 by 2. So the number that should be taken is 7 by 2. If you cannot get this number, just write this number, whatever number is present over here, put that number in the numerator, and whatever extra numbers you are having in the numerator, put that in the denominator, and make that fraction to change it to the simplest form. So that 7 by 2 is the required fraction. This is our b. Next term will be plus b square, so we put a plus sign, and b square, that is 7 by 2 whole square. And since we are adding a 7 by 2 whole square in the equation, we have to subtract it as well. So it is minus 7 by 2 whole square plus 6 is equal to 0. And now we are having these three terms. These three terms, when taken together, will be giving us a minus b whole square form, where a is equal to 2x minus 7 by 2 whole square. So it is of the form a minus b whole square identity. And this is 7 square is nothing but 49, and 2 square is 4. So it is 49 by 4. Right? Plus 6. Or straight away we can, since we are having this 4, it is a fraction and this is a whole number. So this has to be converted to an equivalent fraction. Having 4 in the denominator, that means we have to multiply this denominator. Present denominator is 1. We have to change it to 4. So we have to multiply 1 with 4 as well as 6 with 4. So it gives us a 24 by 4 equal to 0. And this part is kept as it is. 2x minus 7 by 2 whole square minus 49 by 4 and plus 24 by 4. So the sign will obviously be negative because 49 is the larger number. So it will be minus 25 by 4 equal to 0. And 25 by 4 is again a perfect square because it is 5 by 2 whole square. Right? So we have 2x minus 7 by 2 whole square minus 5 by 2 whole square is equal to 0. Again we are getting the a square minus b square form. And a square minus b square is nothing but a plus b into a minus b, and a in this case is 2x minus 7 by 2 and b is 5 by 2. So we apply that identity over here. For a, we write 2x minus 7 by 2 minus 5 by 2. Sorry, it is a plus 5 by 2 because the first is a plus b. So it is, and the second is a minus b. So it is 2x minus 7 by 2 and minus 5 by 2 is equal to 0. Okay. Next, we have both are having the same denominator, and minus 7 added with a plus 5 will be giving us a minus 2. So it is 2x minus 2 by 2 and 2x and minus 7 added with minus 5 gives us a minus 12. So it is minus 12 by 2 equal to 0, and these two will get cancelled. We'll be having a 1, and even these two get cancelled, and we have a 6. So we have 2x minus 1 and 2x minus 6 equal to 0. Okay. Now, when you are having this type of a binomial where there is a common factor, you see we can take out 2. This is 2x and this is 6. So we can take out 2 and we will be having a x minus 3 within the bracket. Okay. So we can take out this 2. Let us do in both the ways. Okay, so let us take out this 2. We are having 2. I'm writing 2 at the very beginning, and then we are writing 2x minus 1. We can write this 2 after 2x minus 1 as well. And we are having this as x minus 3 equal to 0. Okay. Now, we can get rid of this 2 by dividing the entire equation by 2. If we divide this left hand side by 2, we can eliminate this 2. And on dividing the right hand side by 2, it becomes 0 by 2, which is nothing but a 0. So we can eliminate this 2 and we will be having 2x minus 1 and x minus 3 equal to 0, right? So we can take out a common factor. If there is any common factor, we can take out that common factor, that constant common factor, because if it is an x, then of course we can take out an x. It cannot happen for a quadratic equation. It can happen that you may have some numerical factor as the common factor, and you can take out that particular number, and on dividing the entire equation by that number, in this case the number is 2, on dividing the entire equation by 2, we get this, because on dividing the left hand side by 2, this 2 gets eliminated, and on dividing the right hand side by 2, since the right hand side is having a 0, 0 divided by 2 gives us a 0. So we have, this implies either (2x minus 1) is equal to 0, implying x equal to half, or x minus 3 is equal to 0, implying x equal to 3, right? So we have got the two values of x. One is x equal to half and the other is x equal to 3. But what if you do not notice that you are having a common factor. You may overlook this part. Then will your sum become wrong? No, it will not become wrong. Let's see what happens. We will leave this part as it is. We will not be taking out the common 2. And let's see what happens. So these two parts when multiplied together is giving us a product of 0. So either 2x minus 1 will be equal to 0 or 2x minus 6 will be equal to 0. So we write that straight away. That is either two x minus 1 is equal to 0. This implies x is equal to half. Now, or the other part, 2x minus 6 is equal to 0. This implies x is equal to 6 by 2, because in this case we had taken 1 to this side, and so minus 1 became a plus 1 and 2 was taken down and we got x equal to half. Over here also we got x equal to half. Now coming to this part, minus 6 when taken to this side we get a plus 6 and 2 is taken in the denominator. So it is 6 by 2. And again we get a value of 3 for x. So x equal to 3. Even in this case we have got x equal to half or x equal to 3. And even if you do not take out this common factor of 2, you get the same result, x equal to half and x equal to 3. So do not get worried if you do not notice this, that you are having a common factor. Your answer will come out to be the same thing. Okay? So we have got the value of x as half or x as 3. So we write, since it is a quadratic equation, of course x will be having two values. So the two values for x are half or 3. And let's just verify, let's do the checking orally. When x equal to half, we are having the equation as 2x square minus 7x plus 3 equal to 0. When x equal to half, x square is half square, that is 1 by 4. 2 times 1 by 4 is half, and 7 times half is 7 by 2. So half minus 7 by 2 is minus 6 by 2, which is nothing but minus 3 when added to plus 3 will be giving us a 0. So x equal to half satisfies this particular quadratic equation. Now coming to x equal to 3. X equal to 3 means x square equal to 9. 9 times 2 is 18 and 7 times 3 is 21. So 18 minus 21 is a minus 3 when added to plus 3 will be giving us a 0. So even in this case we are seeing that the equation 2x square minus 7x plus 3 is being satisfied by the value of x as 3. So we have arrived at the correct answer. Okay. So we have solved both these two sums correctly. Let us write the answer. And this one is the answer as well. And let us highlight these two. So we have solved the two sums by completing the square method. And what is this method? We have two different cases. First case is when the x squared term is a perfect square term. If we are having a perfect square term for x squared, then we introduce a term, and depending on whether this sign is a minus sign or a plus sign, we get three terms and change it or express those three terms in form of a minus b whole square identity or a plus b whole square identity, depending on whether this sign is a minus sign or a plus sign. And since we introduce a positive term, square term, therefore simultaneously we subtract the very same number and then we add that to the constant term. And the sums are given in such a manner that when we add these two, we get another square term. So effectively we get a square minus b square form. Again, that is another algebraic identity, and that is equal to a plus b times a minus b. And so we get two bracketed terms when multiplied together, giving us a 0. So either this first bracketed term is equal to 0 or the second bracketed portion is equal to 0. So that is how we find the value of x, the two values of x. But in the second case, we have seen that the first term containing the x square is not a perfect square term. In order to make this as a perfect square, whatever is the numerical coefficient, we multiply the entire equation by the numerical coefficient of x squared, so that we get a perfect square term for the term containing x squared. And next we follow the method that we have taken over here for case 1. Okay, we follow exactly the same method as we have followed in case 1. Okay, so this brings us to the end of our session, today's session. Thank you for hearing.